All right. We are going to solve systems by elimination today. Again, a concept in which you have already trekked your way through in Algebra 1. So systems by elimination is solving a system of equations, just like what we did yesterday with graphing and substitution. So what are the three scenarios that can happen when we're solving a system of equations? One solution, no solution, or infinite solutions. Okay, so those same three things can happen when using this method. So no matter what method we're using to solve, those three scenarios are part of the game. So using elimination is where the standard form for linear equations comes back into play. Because when you're doing elimination, you want your problems to look something like these. So these are two equations with the same two variables. And those are pretty close to standard form. The second one is definitely could do a little bit of work there to get it to true standard form. Well, we're not overly concerned about being perfect standard form. We're mainly just concerned about x and y being on the same side. So if we're doing elimination, we want x and y on the same side. Okay. Substitution, you get one of the variables by itself. Elimination, get the variables on the same side. And then you look at each of the coefficients for the variables, and we try to find opposites if they have them. So are there opposites on this one? Where? Yeah, the 3x here and the negative 3x. They're opposites of one another. Because they're opposites of one another, if I just add these two equations together, what's positive 3x plus negative 3x? 0x. They cancel each other out, right? And then we add the y's together. What's 5y plus 3y? 8y. Then we add the numbers on the other side of the equals together. So 26 plus negative 18. How much? Positive 8. Now we got a nice easy one-stepper to finish with. How do we get y by itself for this one? Divide by 8. Y is equal to 1. So there's our y value. How do we get an x value? Plug a 1 in where? Where at? In one of the equations. Doesn't matter which one. No, just pick your one you think's the easiest. I'm going to go with the top one because there's no negative signs in there. So I think that'll be easier for me to do. So I'm going to go 3x plus 5 times 1 equals 26. So I'm plugging that 1 that I got for y in the place of y in one of my equations, and then I'm going to work that out. So that'd be 3x plus 5 is equal to 26. Subtract 5. 3x is equal to 21. And the last step is divide by 3. X equals 7. And our final answer always is an ordered pair, 7, 1. X first, then y. So that's the final answer there, the ordered pair. I like elimination better than substitution, but it isn't always this easy. But I tend to, if I've got a choice, I try to do elimination instead of substitution just because I like it better. If you ask Coach Mack about it, he's a substitution guy. He likes that method better. It doesn't matter. You get the same answer either way out of that. So this one's pretty easy because it had opposites already in there. So let's look at one that maybe doesn't have opposites in there and see how we can do with that. So let's say we had 2x plus 2y is equal to 4, and 3x plus 2y is equal to 3. And that's really, really close to having opposites, but it doesn't. When we're looking at those two equations, we get x and y, make sure x and y are on the same side, they're both in the same order, and then we try to see if they're opposites. Well, we got a positive 2 and a positive 3x. That's not opposites, but we have a positive 2 and a positive 2y. That's almost opposites, right? How could I make one of those the opposite? Make it a negative. The only legal way to make a part of the problem negative is to multiply the entire thing by -1. So I'm going to multiply this entire, I'm going to just do the second equation. I'm going to multiply it by -1. It technically doesn't matter which one you multiply by -1. Just pick one of them here, and that's going to give me -3x minus 2y is equal to -3. Did I do anything to the first equation? No, so I'm just going to copy it over. 2x plus 2y is equal to 4. Now I have opposites, so when I add the two equations together, what happens to the y's? They cancel out, and I get a -1x is equal to +1, and then I can solve for x. X is equal to -1. All right, and then I got to find y by plugging that into one of my equations. Pick your poison. It doesn't matter which one you use there. It's going to get the same answer. I'm going to go to the first one there. 2 times -1 plus 2y equals 4. That's -2 plus 2y is 4. I'd add 2. 2y is equal to 6. Divide by 2. Y equals 3. So an ordered pair, -1, 3. Good job. All right, so we're seeing multiplying one of the equations by a number to get an opposite. In this case, it was by -1 to get that opposite to happen. Let's try another here. Let's say we had x plus 3y equals -4 and x plus 3y equals -2. Well, we got to do something. They don't cancel out right now because if I add them together, it's 2x and 6y, so it doesn't cancel them out. Yeah, so if I make one of them all negatives, so multiply this, I'm going to do the second one by -1. It doesn't really matter. So -x minus 3y is equal to 2. And then the top one is staying the same. And when we add those two equations together, yeah, x cancels x, 3y and -3y cancel out. And then -4 and +2 is -2. What's left on the left-hand side of this, on this side of the equal sign? 0. If everything's gone, there's a 0 left. Does 0 ever equal -2? No. That's a no solution. Spell no solution here. Long day. No solution because that is a false statement. 0 never equals -2. If it were 0 equals 0, what is it? Infinite solutions. Okay, so pretty easy idea there. So they're changing the sign of one entire problem to get an opposite so that they cancel out. Not too difficult. Let's look at number 4. -10x plus y is equal to -15. -5x.
Ashton Waldrop, report to the office.
-5x plus 4y is equal to -25. So we have two equations. They are in the right order, in the right form. So I'm looking to get opposites here. So I've got choices to make because I don't have the same number on any of them. I got a -10x and a -5x. That's not the same. And I have a +1x and a +4x. So they're not the same number. I'm going to have to do something a little different to get an opposite happening here. So you just got to make a choice which one you want to eliminate.
So you could get a bottom to the x's.
Okay, if you want to cancel x's, we multiply the bottom one by what? -2 to make it that 5x turn into a +10x, right? Does that make sense? Is that the only way to do that?
You can do the y's.
I could do the y's as well. If I multiply the top one by what? -4, that would work for that. It doesn't matter which one you do. Just pick one and do that one. Since Micah said the x is first, that's absolutely fine. So that's what we're going to do. We're going to multiply the bottom one by -2. We're multiplying that entire equation by -2. So that's going to get us +10x minus 8y is equal to positive 50. And then I'm not doing anything to the top one this time. Yeah, and when you add these problems together, the x's go away. Negative 7y is equals positive 35 divided by the negative 7. And what is y? Negative 5. Be careful on your signs, because if you miss the sign on the first one that you find, you're going to miss the other one, unless you're extremely lucky and make a weird mistake that happens into the right answer. Not very likely. Yeah, plug it into one of the equations. You can use one of these ones that are written in black. You could use either of the equations that are written in green. It doesn't matter. Just pick whichever one you think is the easiest. I'm going to go to the top one there. Negative 10x plus negative 5 is equal to negative 15. So I just went to that top one there and plugged in there. So I didn't have, that's one less step I've got to do. And then add 5. Negative 10x is equal to negative 10. And x is what? Positive 1. Order pair 1, negative 5. Hey, not too bad. It's just math. Let's see about this one. Let's say we had negative 5x minus 7y is equal to negative 2. And let's do a negative 20x minus, 28y equals negative 8. Can I?
If you could, you could divide that negative 20 by negative 4.
Is everybody else divisible by 4? Then yes, that would be legal. Normally not going to be able to do that, but for this one, yeah, you could. I like that idea that dividing everybody in the second equation by 4, or negative 4, excuse me, that's what you said. That would reduce that. Instead of having to make it bigger, we're going to make it smaller, because everybody's divisible by 4. If everybody wasn't divisible by 4, don't do that, because then you're going to create fractions, and that makes it harder to do. But since everybody was divisible by 4, great idea. So that's going to change that to be 5x plus 7y is equal to 2. And this is negative 5x minus 7y is equal to negative 2. Now what happens when I add everything together? Everybody's canceling. So that's 0 equals 0. It's infinite. And you can just write the word infinite there. That one happened to be a little bit special. But yeah, look for shortcuts there. If everything's divisible by 2, it may not make opposites right out of the box, but it might give you a smaller number to deal with. So look for shortcuts that you can do that with. We generally, in Algebra 1, we were doing this, we didn't have those kind of shortcuts to look for. We tried to keep the problems kind of small. But in Algebra 2, we kind of try to throw some things in there that you might be able to take a shortcut or two on. And that's one of those things. So good job. All right, let's look at number 6. Let's do 3x plus 2y equal to negative 21. Negative 2x minus 3y is equal to 19. All right, so this one's a little tougher. You got 3x and negative 2x. Is there anything times negative 2 that'll get to 3? No, nothing like a nice number. So that's not going to work out good. Well, same thing happens on the y's. So I can't multiply one of the equations by something and get opposites. but I can multiply both of them by different numbers and get a number that they both go into. So what number would be common between 3 and 2? 6. So if I could turn one of them into a positive 6 and the other into a negative 6, then I'll get cancellations happening. So how do I, you make a choice about which variable you want to cancel out. Which one do you guys want to cancel here? X's or Y's? Doesn't matter, it's the same amount of work. Do the X's, I think that's a good idea. Doesn't matter, it's about the same either way. So what do I have to multiply the top one by to turn that X into a 6? By 2. So I'm multiplying the top one by 2 to get 6x plus 4y equal to negative 42. And then what do I need to multiply the bottom one by to turn it into a negative 6? 3. So that's going to be negative 6x minus 9y. 3 times 19 be 30, and 27 be 57, I believe. And then we're going to add those two equations together. Yeah. Divide by 5. Y is positive 3. Go, and once I get here, anytime I've had to multiply both equations by something, I usually go back to one of the originals to plug into because the numbers are going to be smaller. They have to be out of that. So that should be negative 5. Thank you very much for catching their mistake there. That should be negative 5, and we're dividing by negative 5, so that would be negative 3. Ooh, think you caught that there? Because once we plugged it back in, we was really going to miss the X on that. We'd miss both of them on that. So good job. Good looking out. All right. So yeah, it doesn't matter which one of those you plug back into. Pick, whichever one. I usually don't think about it very much. I just pick one of them and plug it in, and it's usually the top one because that's the first one I see, and it doesn't matter. So I'm going to go 3x plus 2 times negative 3 is equal to negative 21. That's going to be 3x minus 6 equals negative 21. Divide by 3. We get x is negative 5. Ordered pair. Yeah, be careful when you go to write that ordered pair. You get it in the right order. Get the solutions out of that. So multiplying both of those equations by something can definitely help you get there if need be. All right. Last one. I said we were going to do 8. Let's just do 7. You guys seem to be on it today. So let's go negative 5x plus 5y is equal to 6. 8x plus 7y equals 21. Hold on, that's not 6. Let's make that, that's supposed to be 15. I read the wrong problem. There we go. That'll work out better. Now, you're looking at these. You're trying to get either x or y to have opposites on one another. So you want to look at the coefficients and think, what numbers do they have in common? And I usually try to look for the smallest number, but that doesn't always have. You don't have to do that. 8 and 5, what's their common number? That both of them go into 40. 7 and 5, what's their common number? 35. So not much difference there either way. If one of them was like 100 and something, and the other one was like 30, I would definitely go with the 30. With one being 40 and one being 35, doesn't make much difference. They're about the same size. So because the x's already have the opposite sign, one's positive, one's negative, I think that's the ones I want to eliminate. That way I don't have to enter in a negative in the problem. So those are the things you want to kind of think about here. What can make my life easier? Do I need to put an extra negative in here or not? If I can avoid that, do that. So what do we multiply the top one by to turn it into a 40 or a negative 40? 8. And the bottom one by 5. and that'll give us negative 40x plus 40y. 80 plus 40 would be 120, and then that'd be 40x plus 35y, that'd be 105. And then we're going to add those together. The x's go away just like we planned, and then 75y 225. That's what I got. And then divide 75, and I got 3. And we need to plug that in to one of those equations. It doesn't matter which one. I like the bottom one on this one because I don't have any negative signs. So I'm going to use it. 8x plus 7 times 3 is 21. So that's 8x plus 21 equals 21. All right, 21. 8x is equal to 0. Well, it's got an x with it, so is x by itself yet? No. What's 0 divided by anything? 0. So we do get an answer there. The only time you're going to worry about true or not true is if the variable completely goes away. If it cancels out completely. Here, the variable is still in there, so we know we got an answer coming out of it. So ordered pair would be 0 trace. Again, with these, there's systems of equations. You can take your answers and plug in to the original problems for x and y, and they should work in both of them. Okay? Questions? Pretty easy day today. You got